Hello students, my name is Dr. Smita Sharma and currently I'm working as an associate professor in the IML and Cybersecurity Department of SIRT Bhopal, and today we are going to discuss on the topic switching technique, which is one of the most important topics that need to be covered in your syllabus of computer network and data communication. So, why we need to study about the switching technique? See, as we all know that in internet we have various types of network. Okay, so what happens in large networks? Obviously we will have multiple paths that link together the sender and the receiver, and we need to have various communication channels also, and your data switches between various communication channels. Okay, and it will also select the route. So the main aim of studying the switching technique is it will decide the best route for data transmission. As in network, we will have multiple paths or multiple links that will connect the sender and the receiver. And they are basically used for one-to-one communication. As we all know that in computer networking, we have one to many, many to many, and many to one. But when we talk about switching technique, it basically concentrates on one-to-one communication. Okay. So next, we talk about the classification of switching technique. So when we talk about the classification, it is broadly classified into three types, that is circuit switching, message switching, and packet switching. And then the circuit switching is further divided into two types, that is phase division switching and division switching. Similarly, packet switching is further divided into two types, datagram switching and virtual circuit switching. And further, virtual circuit switching is divided into again two types, that is switched virtual circuit, that is also known as SVC, and permanent virtual circuit, that is also known as PVC. So we will cover each topic in sequence. So, what is basically a circuit switching? So, the main aim of circuit switching is what? To establish a dedicated path between the sender and the receiver. What is the meaning of dedicated path here? Dedicated path means once a path is established for communication for a particular data, it cannot be used to transfer any other data. Okay, so once the connection is established the between the sender and the receiver, until the entire data is transmitted, that connection will not be terminated, and cannot also be shared also. Okay. So what happened in this? Once a request signal is sent to the receiver when the data is available, then if the receiver is ready to receive the data, then it will send back the acknowledgement. Okay, that will ensure that the dedicated path is available and no other data is being transmitted right now between the sender and the receiver. Okay, so once the sender receives the acknowledgement, what happens? Once the sender will receive the acknowledgement from the receiver, then the dedicated path established and the transferring of data will take place. Okay. And the next important point in circuit switching is we can only transfer the fixed amount of data. Okay, the variable data cannot be sent. We just before starting the transmission, we will decide that this much amount of data is need to be transferred, and only that data will be transferred between the sender and the receiver through the dedicated path. Okay, so in circuit switching, communication takes place according to three phases. Okay, first is circuit establishment, and second is data transfer, and the third is circuit disconnect. So what happens between the circuit establishment? Sender will send a request to the receiver, and then the receiver will send the acknowledgement. After that, the data transfer will take place. And once the data is transferred, the dedicated path will be disconnected. It means the third phase will be completed, that is circuit disconnect. Okay. So here we can see through the diagram also. Here A is the sender, B is the receiver, and S1, S2, S4, these all are the nodes. Okay. And here the every message will transferred as a whole. Okay. And once the transmission is completed, then the link will be terminated. Okay, and each message will follow the dedicated path. Again, as I already told you, circuit switching is divided into two technologies, that is space division switching and time division switching. Okay, so what happens in space division switching? Here, basically, we work on the cross points. Okay. Here, basically, a single transmission path is accomplished by using a set of cross points. So, cross point is, and these set of cross points are established using crossbar switch. Okay, that are made using the semiconductor. So, because of the crossbar switch, space division switching has the advantage of high speed, high capacity. Speed means the data transmission is takes place at a high speed, and high capacity means large amount of data can be transmitted between the sender and the receiver. And non-blocking switches. Non-blocking switches means once the data is transmitted, until the transmission is completed, the dedicated path cannot be disconnected. Okay, so this is the diagram of crossbar switch, which shows that we have n inputs and n outputs, and we have n square cross points. Okay, in a particular crossbar switch. So this is the diagram that shows that we have n inputs, n outputs, and n square cross points between the input and the output. And the data transmission will take place through these cross points. Okay. So the one of the disadvantage of crossbar switch is as the number of stations, it means as the number of nodes increases, the cross points will also increase. Okay, and switches are also very expensive. So to resolve this problem, we need to use multi-stage switch. Okay, to overcome the disadvantage of cross-point switch, that is, it is very expensive, and the cross points also go on increasing as the number of nodes or the station increases. So for this, we need to use multi-stage switch. Okay, so what happens in multi-stage switch? Here, the crossbar switch is split into smaller units, and then they are connected. Okay, so in it also reduces the number of cross points. Okay, and one of the most, if you talk about the advantage, the major advantage of multi-state switch is that if one path fails, the data can be transferred to another path. It means the entire network will not get down. Okay, if one path fails, it can easily continue the transfer of data to another path. Correct? So that is the major advantage we can say of multi-stage switch. So here we can see that Yeah, the crossbar switch is divided into multiple stages. Here we are seeing that we have three stages, stage 1, stage 2 and stage 3. Okay, where all the three stages are interlinked with each other. Here the diagram shows that a particular crossbar switch is divided into multiple stages. Okay, and they are internally linked to each other. So, if we talk about the advantages of circuit switching, as we have already discussed about it, here we use a dedicated path for transfer of data between the sender and the receiver. Disadvantage, if we talk about the disadvantage, as we are using the dedicated path, so it cannot be shared, okay, until the data transfer is complete. And the next disadvantage is it is expensive. The switches are very expensive. That the crossbar switch that we have discussed is also very expensive for when we use for interactive applications. And obviously, as we have already discussed, that once the dedicated channel is established, it cannot be shared. So obviously, it shows that it specifies insufficient use of communication channel as it cannot be shared. Okay. So next is message switching. What happens in message switching is here, the message is transferred in a entirety. It means as a complete unit. Okay, and one of the technique that is used in message switching is that we use store and forward switching. Okay, what happens in store and forward switching is there are intermediate nodes in message switching, and the data is stored in the intermediate nodes in its entirety, and then it is transferred to the next node. Okay, that's why it is also known as store and forward network or switching. Okay, and the here we don't need to use the dedicated path between the sender and the receiver. It means it can be shared among the different data. So here we can see also understand through the diagram that every message has its own path. They are not using a specific dedicated path between the sender and the receiver. Through red lines, we are showing the path that is used by message 1 to be sent from the sender to the receiver. Similarly, from A to B, we are the blue line shows the path that is used by message 2. It means they are not using the dedicated path to be sent between the sender and the receiver. Okay, and each intermediate node will receive the data and will store the data until it is received in its entirety, and then only it will forward the data to the next node. So, if we talk about the advantages of message switching, so as we have already told that there is no dedicated path between the sender and the receiver, obviously it improves the efficiency of the available bandwidth. Okay, and traffic congestion can be reduced through store and forward technique that is used in message switching, as every node store the data in its entirety and then only it forwards the data to the next node. Okay, so it also reduces the traffic congestion in the network, and it also supports the data of any size. There is no limit of the data that can be sent between the sender and the receiver. It can be of any size. These are the advantages of message switching. Now, if we talk about the disadvantages, so the long delay can occur. What is the meaning of this? So, as I already told you that